All right, it's time. We can start our second session. The second session is about blockchain infrastructure and network challenges. And our first speaker will be Simone Romano from IoTeX. He graduated in computer engineering from the University of Napoli and specialized in industrial automation. He's worked in industrial machine vision for over 15 years, holding multiple patents. And he's the developer relations lead at IoTeX since 2020. Focusing on industrial technologies and blockchain with the goal of applying blockchain technology to decentralized physical infrastructures. And his talk is about building decentralized physical infrastructure networks. With that, I would like to hand over to you.
Thank you. Can you hear me? Yeah. So yeah, good morning, everyone. Glad to be here. And thank you to the Technical University of Munich for having us. My name is Simone, working in developer relations at IoTeX, a blockchain project that started in 2018, focusing on the research in the intersection of blockchain with IoT and machines. Yeah, today I want to explore with you this revolutionary field, which is reshaping somehow the way we build physical infrastructures. And it's called DePIN, which stands for Decentralized Physical Infrastructure Networks. So what are DePINs? So DePINs are based on three core technologies, which are blockchain, IoT, and token economies. And the idea is to incentivize communities to build decentralized physical infrastructures and machine economies from the bottom up. And so, unlike traditional IoT applications, where usually there is an organization or a company behind a project that is willing to invest lots of money at the very beginning to bootstrap such applications, projects that are based on the DePIN principles try to incentivize communities and people to build a certain type of application for the common good, and applications that can provide some sort of utility for everyone. And so in the coming slides, I'm going to just go through some examples of DePIN applications, the current limitations of DePIN systems, a possible architecture to decentralize the DePIN logic that address these limitations, and what IoTeX provides in terms of tools and infrastructure to advance this field. Now, DePIN is a pretty complex and very large field because it not only involves blockchain, but it also involves hardware, protocols, middle layers, processing, and many other layers. So I'm just going through giving you an overview of this space, and I'll do my best to answer your questions later if you want to go deeper into any specific concept. So according to the classification from Massari, there are basically two categories of DePINs. PRN, or physical resource networks, which basically incentivize people to deploy location-dependent hardware to provide some non-fungible goods or services. And in this case, the location of the hardware is pretty relevant. And DRN, or digital resource networks, which incentivize people to provide some fungible digital asset, such as computing power, or data storage, or bandwidth. And in this case, hardware can be deployed just everywhere. So let's start with some examples in the decentralized, into the digital services infrastructures. And that's because these are more popular. These have been developed earlier into the Web3 space, and there are quite some established projects and startups providing these types of infrastructures. So one pretty popular one is a decentralized infrastructure for data storage. In this case, users are required to join the network by deploying some storage device, usually on their own workstations, but also why not mobile phones, or mobile phones more for processing than for storage. But anyway, the result is to create a public network for file storage. And in this field, there are pretty popular projects like Filecoin that provides a decentralized network for file storage, or Airwave for data storage, or Storj also for data storage. Another popular example into the digital resources are decentralized infrastructures for processing power. And in this case, the network is coordinating multiple user-owned workstations or mobile devices to create a public service for processing power. In this category, there are applications that provide both decentralized computing power in general, but also other applications that provide specific computational resources. For example, for the building of AI models is a popular emerging field. But as well as there are similar digital resources protocols, like, for example, ORCID that provides VPN services or DNS services in a decentralized fashion. More interesting recently are emerging DePINs, which are based on physical resources. So some examples in this case are, one popular one is a decentralized infrastructures for energy charge, for energy sharing. In this case, users that have the ability to produce energy, for example, by solar panels or wind generators, are incentivized to deploy some energy EV chargers, for example, for cars, to create a public utility, a community-owned infrastructure for energy sharing. In this space, for example, there is PowerPod, who is building a decentralized EV charging network for cars. Another example this is another popular one, a decentralized infrastructure of 5G connectivity. In this case, the protocol coordinates multiple user-owned 5G antennas to create a public service for cellular connectivity. Popular players in this field are Helium, that provides a decentralized cellular connectivity network, but also Wiro, for example, that provides a decentralized Wi-Fi connectivity network. Another possible, maybe in the near future, example in this case could be an infrastructure for shipping packages through drones, where people are incentivized to join the network with their own drones to create a public utility for shipping. Another example worth mentioning, which still falls into the physical resource networks, are decentralized infrastructures that collect data, location-based data, for example, weather stations. In this case, you can crowdsource data from multiple weather stations or other devices to create community-owned data pools that then can be monetized in some way. Examples are WeatherXM, that is building a community-owned weather network, but also, for example, Spexigon, who is building a decentralized Earth imaging network based on drones. So if we look at the DePIN landscape, it's pretty clear that there are so many startups already, focusing on all kinds of different services in physical resource, digital resource, as well as building DePIN-specific modules and tools. And all of these projects are trying to figure out how to bootstrap and create these networks that provide some sort of utility, and how to grow them to a large-scale network, probably a global-scale network. So yeah, in these slides, I've just split the physical resource examples category into those that require a specific device. For example, Helium requires that you buy their hardware, their 5G antenna and router to join their network. Also WeatherXM requires you to buy one of their weather stations to join their network. As well as there are physical applications in the physical resource category where you can bring your own hardware. For example, Wi-Fi Map, which is building a decentralized map of Wi-Fi connectivity. You can join the network with your own Wi-Fi hardware. But also Spexigon, that I already mentioned. You can join their network with your own drone to provide high-resolution Earth images. And this is the DePIN landscape in the digital resource, which is pretty bigger, actually, because, as I mentioned, it was started earlier than the physical resource category. So if you are interested into DePIN, the DePIN landscape, these startups from curiosity, out of curiosity, or from an investor point of view, we at IoTeX, among other things, also built this like DePIN scan, which is for a tool for the public good in the DePIN space, where we list all DePIN projects, not only with tokenomic information or financial information, but also providing real-time data on the location or the actual data streamed by the different devices from these different projects to help give an idea of the growth of the space. So one important thing that's important to stress is how DePINs are different from traditional Web 2 IoT systems. In traditional systems, there is a relatively stable business model where a company provides a service to their customers and they just get a revenue back. DePIN, on the other hand, tries to disrupt this traditional model by creating these token-incentivized community-owned networks. And what you see in this slide is the typical flywheel of a DePIN project that allows to bootstrap and move the protocol forward thanks to the contribution and participation of the different roles that are part of the network. So once one project is bootstrapped, thanks to some token incentives backed by some maybe investment, the demand, so it's just bootstrap, right? So the demand for its specific utility will start to show up somehow. With more demand, there is usually a higher value of the token that is actually usually utilized in some form to make use of the network utility or service. So more miners are interested in mining this token because the value grows, and so they are incentivized to join the network with more hardware, and so the network grows, and maybe to the point when where other projects or builders decide to integrate with this network or to build on top of this network by generating further demand, and so more token value, so more incentive for miners to join, and so the growth of the network, and so more demand, and so on and so forth, into a self-sustaining ecosystem from bootstrap to global scale, hopefully. So here is a very high-level architecture system architecture of a DePIN application. Usually you have some devices that you deploy in the physical world to either monitor certain activities, collect or track data, provide some utility like computing resources or storage resources, and so on and so forth. This data, or I should say more correctly, some insights extracted from this data, is then somehow sent or proven to the blockchain. And the role of the blockchain is to orchestrate the whole DePIN project. On one side, you must have a governance layer that's deployed on the blockchain that basically keeps track of the different roles, who can do what, right, into the ecosystem. And on the other side, you also need to deploy some sort of token economy as an incentive layer to align the benefits for the different stakeholders. And these two layers are, of course, deployed on the blockchain. So we have like some insights extracted from the data from devices that are deployed in the physical world that eventually trigger smart contracts on the blockchain. And these smart contracts executions can be usually incentivizing with rewards some people, or penalizing or like punishing somebody else that's not behaving as expected by the protocol. So clearly, the main components of a DePIN project are IoT systems and blockchain. And so it's worth taking a quick look at the special characteristics of these two systems. So DePINs are usually large-scale networks because they are IoT applications, and possibly they are at a global scale. So they are expected to not only have a huge number of users and stakeholders, but also they are supposed to deploy a large number of devices in the physical world. And these devices, during their operation, will generate a large volume of data that gets continuously processed. On the other hand, blockchain while it provides a very high degree of trust to the point that it can really be the main anchor trust for the entire DePIN system. On the other hand, it has very limited processing capabilities, as well as it's very expensive in terms of data storage on-chain. So we clearly have a scalability issue in DePIN applications. And that's the main reason why the current state of DePINs is basically that they are built and designed and managed like a typical Web2 IoT application, just with the addition of some, usually a token deployed on the blockchain. And basically, by using the modular infrastructure that's typical of these Web2 IoT systems, a DePIN project usually has a cloud that serves all the different requirements for the IoT logic. So from user management, device management, data streaming, data storage, data processing, and until at some point this logic is going to trigger some token rewards on a blockchain. But now let's explore how actually an architecture for a DePIN might look like. So we have like come to this possible architecture. So when you want to design a fully decentralized infrastructure for a DePIN project, taking a look at how centralized cloud and IoT applications have evolved is definitely providing a lot of good insights. And in fact, these systems clearly show the benefits of a modular design that specifically in IoT systems can adapt and fulfill the diverse technological requirements due to the heterogeneity of devices, protocols, and different IoT requirements. So building a modular DePIN applications for sure involves a complex tech stack that is made of many composable and modular layers, as illustrated in this slide. So basically we have 6 main layers, starting from the hardware abstraction down to the blockchain, plus some like vertical layers that intersect all or most of the main layers, and then some additional like optional layer that can interact with some of the main layers. So let's quickly go through all of them. The hardware abstraction layer is typically in the form of a lightweight embedded SDK that usually provides for a wide range of popular IoT platforms, provides the primitives, the cryptographic primitives to facilitate the creation of Web3 entities and the interaction, of course, with data streaming protocols. So I'm talking about mainly interacting with the DID, the decentralized identity layer, and the generation of trusted identities, trusted data, and the streaming of this data that goes to connectivity layer that typically there already exists some decentralized layer at this level. For example, Streamer that provides P2P streaming, data streaming, decentralized infrastructure, or Nodal that provides a Bluetooth connectivity, but Helium itself provides 5G or LoRaWAN connectivity in a decentralized fashion. So the purpose of this layer is basically just to provide the typical IoT streaming protocols and features. Then once the data is streamed out of the device, it's going to what we call a sequencer layer. Similar to what a sequencer layer is in a ZK rollup system, just there is not much agreement yet on what a sequencer layer should do for a DePIN application. But in general, it's going to deal with interacting with the identity layer to authenticate a device, validate the data, maybe filter the data, make sure it's consistent, it's compatible, it's uniform, and maybe it's sorted right, in some way in such that it can then be injected into the processing layer, into the off-chain processing layer. So once this data has been filtered and cleaned up and validated, it's ready to be processed, but that's also where it goes to first some data storage that can be, depending on the requirements of the DePIN application, can be a data availability layer that acts as a sort of a buffer where the data gets stored before processing, and or a long-term storage, depending on the requirements of the DePIN application. This layer has to be very flexible, and the different projects have different requirements. So eventually, this data availability layer that becomes the input of the data processing layer stores usually blocks of data ready to be processed into the off-chain computing layer. And the off-chain computing layer basically fetches these blocks of data, is in charge for processing them, possibly in a verifiable way, and generate some validation, some like a validity proof to be sent to the blockchain contracts. At this layer, there is not that much, except, I mean, there are some general purpose off-chain computation protocols. We at IoTeX provide WebStream, which is a DePIN specific. It's ZK based, but we also support TEE for a decentralized network of data, DePIN data processing for generating validation proofs, validity proofs. And yeah, the blockchain layer, as already mentioned, it's where basically the token economy and the rest of the trusted logic, including decentralized identities and all the business rules, trusted business rules, lives for the DePIN application. And the identity layer is one of the most important ones, as it should provide both on-chain and off-chain identities. On-chain, it should be able to allow the registrations of like identities for users, for machines, for projects, both in the form of, for example, just wallets, blockchain accounts, or account abstraction wallets. Off-chain, you have like decentralized identities documents or SSL certificates, for example. So IoTeX was started in 2018. Our research in the intersection between blockchain and IoT led to a lot of products, starting with a very solid layer 1 blockchain that provides EVM compatibility, 1,000 transactions per second, instant finality that becomes like the source of trust of the entire IoTeX stack. In addition, we have also worked a lot on trusted hardware, which led to the creation of mass-produced and adopted devices like UCAM or Pebble Tracker. I'm not going deep into this like research now, but it's fundamental to understand the hardware abstraction layer, how it should be built, and how devices should be also designed. IOID is our infrastructure for decentralized identities, which provides both on-chain identities and off-chain infrastructure to resolve these identities. IOConnect is an hardware abstraction layer in the form of an SDK that currently supports some popular IoT platforms that is capable of generating identities and interacting. That's all. And yeah, if you are interested in DePINs, in IoTeX, feel free to reach out to me. If you have any questions now, I'll do my best to try to answer them.
All right, great. Do we have any questions from the audience for our speaker? One question.
Thank you for this very interesting presentation. So you already mentioned that probably there are bottlenecks right now, and from an IoT perspective with very lightweight, maybe sensor nodes and these things, can you give us an intuition how much overhead is created in such an infrastructure where you would try to think this through from end to end probably, and therefore you cannot completely abstract then the Web3 idea away from the lightweight devices? Yeah,
one of the first problems you have when you want to build this like DePIN projects, or to be more clear, when you want to intersect blockchain with IoT, is that there are already existing IoT devices, and hardware is hard to modify, hard to design, hard to program. And so, of course, you have to go through some like steps before you can actually create Web3 ready devices. In any case, the infrastructure you have seen here is pretty flexible. You can have powerful devices, or you can have very simple devices. The main thing on the device side is actually the, let me see if I have a slide here. The data collection. I mean, you can have powerful devices that are capable of doing zero-knowledge processing to generate already a proof of something that happened in the real world, if this proof only depends on what the device is doing. However, if you have a simple device, you must have you have a problem of trusted data collection. That's the main problem when you want to interact with blockchain, when you want to build a blockchain application that's based on device data. And this trusted data collection relies on the ability to be able to authenticate a device on-chain. So that's why the DID component. So it's not that much overhead. It's mostly about implementing cryptography layers that allow to generate some identity, and possibly, if it's a new device, to leverage trusted execution environments on the hardware, at least to generate the private public key that becomes the anchor for the identity on-chain. If you have even simpler hardware that doesn't have this like hardware or cannot do much, you usually have a gateway that can collect the data, has a secure connection between the sensor, and then the gateway has the capability to be identified on-chain and like generate trusted data, usually signing also the data with its own identity. Yeah, sure.
One more question in the back. I think we have time for one more question.
Hi, thank you for the presentation. I want to ask you about the data. So just imagine we are using the phones, something like that. So we are collecting data. So is it possible to manipulate it and manipulate the chain in the same way?
Yeah, of course, one of the main problems, that's the Oracle problem in a more general way, right? You are injecting data or insights processed on the data, and how, that's the problem of data provenance, right? Can the data be tampered with? We did some experiments. We built a Pebble tracker, which is a Web3 ready general purpose IoT tracker, which has GPS and sensors and everything. It depends how secure you want to be, right? What's the incentive to like tamper this data? The more like you implement hardware trusted execution environments, which means having a private key basically stored in a tamper-proof hardware, right? And then this private key is used by the hardware to sign the data, right? And then the public key of the hardware is stored on a decentralized identity on-chain. Then that data with the signature can be verified in terms of knowing which hardware exactly generated that data. If that hardware has an identity on-chain and it's bound to my project, I'm almost sure that's my device. And if I built it with good security, tamper-proof firmware, tamper-proof hardware, I'm pretty convinced that the data has not been tampered with, right? Otherwise, the signature would not match. How secure, it depends on the usual security issues, right? And it depends on the projects. So the mobile phones in particular, it's hard because you cannot control the trusted execution environment that's into mobile phones. So making sure the data is actually coming from your mobile application, it's a different thing other than if you are building your own IoT device, which can only run a single firmware. So yeah, mobile phones are a little bit tricky, but everything goes down to identifying the device and, of course, signing the data.
All right, great. Thank you. We thank our speaker very much.